And I will hand it off to Vinay to say hello, and then we will jump into a session. Remember, Slack is the home of, oops, if I could find the right one, the home of Q&A. So ask your questions there, and we will get those answered.
Hey everyone, super excited to be at the conference. Just wanted to drop in a couple notes. I ended up creating a FAQ website last night, and I've shared it on the same Slack channel. I would encourage you all to go take a look at it. Hopefully, some of your questions are answered. Apart from that, also make sure that you attend the code lab. I think the true power of Compose is experienced when you actually play with it. So just set it up, make sure that it's ready to go when you want to play with it, and you won't regret it. And the last thing I want to say is that all views expressed in the talk are my own and they don't represent my employer. On that legal note, let's get started. Hey everyone, welcome to my talk about learning Jetpack Compose by example. My name is Vinay and I work at Airbnb. Before we even start learning about Jetpack Compose, let's first learn about why we even need Jetpack Compose. The first reason is that the current UI toolkit is tied to the Android operating system. What this means is that if the Android team were to make any improvements to the Vue system, for example, any bugs in the Vue.java file, we will have to wait for an entire API release to get these improvements. It's not a simple library that I can simply bump up to get these improvements. Unbundling the Vue system from the OS would make it easier to quickly fix bugs and bring improvements in a backward compatible way. State management is, in fact, very tricky. The way we manage UI state has always been this complicated dance that we have to do as views store their own state. And we need to make sure that the state that we store in our view models and presenters is in sync with the state inside the views. For example, if my business logic requires me to hide a view, that logic is probably stored in some view model or presenter. And then as a reaction to that requirement, I need to get hold of that view, then explicitly hide it by calling the set visibility method, which in turn changes the internal state of the view. This is super error prone, and majority of our bugs in the app are stem from state management. So there has to be a better way. Let's talk about the average workflow of an Android engineer. We typically create views in XML, then create our screens which have life cycles in them using Kotlin and Java. Hopefully you're using Kotlin. We then reference the views that we originally created in XML using IDs or tags, and then update its state. When we need to reference styles and dimensions, we again store them in XML. This constant context switching definitely has some impact on our productivity, but we've unfortunately accepted this. Now, some folks might say that this is in fact a good thing. Like there is decoupling between UI and business logic in XML and Kotlin. Decoupling is supposed to be good, right? Well, that's true, and decoupling is a good engineering practice, but this is not really decoupling because you're still referencing these XML views that you've created in your Kotlin files and making modifications to it. So even though that you might think that XML is decoupled and your UI code is decoupled, in reality, it's just an illusion. Simple things also require a lot of code. Like imagine creating a list in classic Android. We create a recycler view, then create adapters for it. If your list has different view types, you override a different get item type method. So there's a lot of code that you even need to write for simple things. The easiest way to write less buggy code is to write less code. And I think we've reached a point where we really need to figure out a way to do that. This talk is called Learn Jetpack Compose by Example, and so we'll be focusing most of our time looking at examples itself. But before we do that, some quick notes. The first thing I want to say is that all the examples that you see today are based on the Dev 14 release of Jetpack Compose. The reason I need to say this is because things are constantly changing as Compose is still in pre-alpha. And so, like if you see an example in the video that has since changed, I promise you that the repo that I maintain will be up to date, even though this video might not. And the next part is that Compose is expected to reach its alpha release in the next few months. They've said that it's going to be in the summer of 2020 itself, so hopefully in the next couple of months. With that said, let's dive right in. It's only fair that the first example we see is a hello world example where we are trying to render some simple text on screen. Here, we are simply creating a simple activity and overriding the onCreate method. Very standard stuff that we are used to doing on a daily basis. Next, we're using a method called setContent. Now, you might remember a method called setContentView, where we would pass the layout that we are using in the activity. But that's not what we are using here. We're using a different method. So let's look at its definition and understand what it needs. We see that setContent is an extension function on component activity. Now, you might be wondering why we are able to call this method, because isn't this an extension function of component activity? But we weren't using that. We are able to use this because app compare activity indirectly extends this. Next, we see that it accepts two parameters. The first one is a recomposer, but it's also passing a default value to it. Since we will be using the default value in most cases, we don't need to worry about this. The next parameter is the content, which needs to be a function that returns a unit. That means we won't be returning a value if you're using Kotlin, which by the way is a requirement for using Compose. You have to write code in Kotlin. This function is annotated with the add composable annotation. Now this is new and we've never encountered this before. This in fact is the secret sauce for Jetpack Compose. Annotating a function with add composable allows that function to describe UI. There are some exceptions to this, but we don't need to worry about that. So what we know till now is that I can describe UI by passing a function that is annotated by add composable. In order to understand the significance of add composable, it is important to know that Compose uses a custom Kotlin compiler. What this custom Kotlin compiler does is that it changes the function definitions of functions that are annotated with this annotation, and it does this at compile time. This is critical for Compose to work because the changes that the compiler does is what allows it to keep track of the changes in these components itself. Now that we know how setContent works, let's go back to our example. We set out to render some text on the screen, and we do know that setContent accepts a composable function as the parameter. So that's what we need to pass. Compose comes with a very simple composable function called text that allows you to render some text on the screen. So that's exactly what we'll use. And we'll also pass in hello world as the parameter that it accepts. Let's try to run the app, and since build times take some time, I try to emulate that as well. And our app is ready to run. And here we go. We are able to see some text on the screen being rendered. Since we did not define anything about how to render the text, it just shows it in the default location, which is the top left corner. So just to make it clear, the composable you pass to set content is the root composable function. In our case, it is the text composable that we pass to it. Moving on, the next thing to note is that when you call a composable function, you can only call it from other composable functions. In that regard, it is very similar to coroutines where suspend functions can only be called from other suspend functions. So what we did here was directly pass an existing composable function. But what if I wanted to create my own composable function? How do we do that? Creating a custom composable function is super simple. All we need to do is create a function, annotate it with the add composable annotation, and then inside the function, we define the logic to render our UI. In this case, we use the same text composable that we saw before and pass in the appropriate string. From a principal point of view, however, we would like to create composable functions that are easily reusable across our apps. However, we are using a static string before. So let's make some changes here. What we'll do instead is pass in a parameter into this function, which is the display text, which is the text that we want to display. We also pass this parameter forward to the text composable. In addition, the style that we were using previously was slightly boring. So let's even change that. Text composable accepts a text style parameter which is nothing but a data class with a bunch of properties. So we're going to override some of those properties and change them. In specific, we're changing the font size and the font family. And now let's try to run the app again. And we see these changes reflected instantly. One last question that you might have is that how is this text composable even showing things on the screen? What if I wanted to create something like that? So this is a totally reasonable question, and ultimately everything that is inside a composable function is basically drawing things directly on the canvas. It's actually much more complicated than a simple canvas.draw text method call. But just to simplify these things, everything that a composable is doing is basically ending up directly on the canvas, and that is how it works in an oversimplified fashion. Another things that Android Studio lets you do is that you can preview your composable functions within the IDE itself. And this is a super useful feature that I've been using a lot. What you basically need to do is your composable functions need to be annotated with another annotation called add preview. There is a requirement for this annotation, however. You can only use this annotation on functions that don't accept a parameter. So if you do have a function that is accepting a parameter, what we can do is create another function and wrap this function inside it. And that is what you see here, where we created a function called custom text component that accepted a parameter. And so we wrap it inside another function called custom text component preview. Let's see at what this looks like in the IDE. Um, this is basically how you will see the preview. And it comes with an additional super useful feature, which is that you can actually run these previews and deploy it directly to your emulator or your device, which again is super useful because then you don't need to run the entire app. You can, in particular, just run this composable function. In addition, what you can also do is actually interact with these composable functions right from the IDE. So what you see here is that we have created a bottom navbar component and you're able to play with it. Don't worry about how this is implemented. This is just meant to be a demonstration of what interactive composable functions in the IDE look like. And I think this is again a super useful feature that we will see ourselves using a lot. Let's look at another example. This time, we're going to try rendering an image on the screen. We'll start the same way that we did before, which was to create a function and annotate it with the add composable annotation. Next, we're going to make use of a helper method that Compose gives us, which allows us to load an image asynchronously. It takes in a drawable resource, and that's what we are going to pass to it. Since the image is loaded asynchronously, it's going to return a deferred image object. And so we need to do safe checks to ensure that the resource is actually available by doing a non-null check. When the object is loaded, we pass it to an existing predefined composable called image. You will also notice that in addition to passing the asset, we also pass the modifier to it. Modifiers are your best friends in Jetpack Compose. You can think of modifiers as implementations of the decorator pattern that are used to modify the composables that it's applied to. It adds functionality to a composable, and majority of the predefined composable functions accept a modifier parameter so that you can change its behavior. In this example, we make use of the preferred size modifier, which takes in a size for specifying the height and width of that composable. There are multiple variants of this modifier where you can also specify the height and width separately. The other interesting thing to notice is how we are able to assign DP dimensions without using any XML resources or any complicated conversions. DP here is actually an extension function on the int type. It returns a DP class, which is a first class citizen in Compose. This makes it super easy to have constants in code itself without needing any XML values or files. Like we did before, we will try to make this composable function more generic by passing any drawable resource, and then we should be able to render it. Let's try and run this app and see what we see using this composable. We see that the image successfully loads now. Let's take a look at another example. This time, we're going to try showing an alert dialog on the screen. I believe that after we go through this example, it will be very clear about what it means to use declarative programming. Whenever we wanted to show a dialog on the screen in classic Android, the code typically looks something like this. We would use the builder, set properties on the alert dialog, and whenever we were ready to show the dialog, we would call the show method on this object to render the dialog. Now let's look at what we would need to do to build it in Jetpack Compose. We'll start off the same way as we did the previous two times, where we create a function and annotate it with @composable. We're used to this by now. Next, we're creating a mutable variable called showPopup, and then we're calling something called state and passing the false value to it. Now you might be wondering what state does because we've never encountered this before. In order to know that, it's important to know that reacting to state changes is the core behavior of Jetpack Compose. State itself is also a composable, and we give it a value to hold on to. Anytime the value of this variable changes, the composables that use this value are automatically redrawn and updated. It's almost like this composable subscribes to this value. The redrawing of this composable is called recomposition. It happens in a very efficient manner, and only composables that use this value are recomposed, and the rest remain as is. There are very similar concepts in other declarative UI frameworks like React, and Compose is inspired by these declarative frameworks. Let's go back to our example. So we're going to add a few more things because we want to show the alert dialog when the button is clicked. We're going to make use of the button composable. We've already seen this before. The only thing that we are changing here is that we are passing a callback to the onClick property that this button accepts. And we are changing the value of this variable inside the callback. So anytime the button is clicked, we're going to change the value of show popup to true. The next thing we will do is write some basic Kotlin code. What we are doing here is checking if the show popup variable is true. Whenever that is true, we want to display the alert dialog. And in order to do that, we'll just use the predefined alert dialog composable. It takes in a few properties. The first one is the on close request, which is basically the callback that we want to call when the alert dialog is dismissed. In that callback, we basically change the value of the show popup variable back to false. This example is also where declarative UI really stands out. Whatever code path is executed during a composition or a recomposition will affect the UI that is rendered on the screen. When the show popup value is false, only the button is shown on the screen. When we toggle at that value, the code path that has the alert dialog is also executed, which in turn causes the alert dialog to be shown on the screen. This is super powerful because we are basically writing Kotlin logic to modify our UI. Let's actually run the app and see it in action. And as we can see, when we click on the button, we see the alert dialog pop up. If you look closely, you will also notice that the button is also visible in the background. What if I wanted to change that? What if I just wanted to show the button and when I tap on it, make the button disappear and only show the alert dialog? It's super simple because of how declarative UI works. All I will have to change is basically make it an if-else condition where if the show popup variable is false, I only show the button. Otherwise, I show the alert dialog. And so these become mutually exclusive. And you can see that in the screenshot as well. And this is basically how declarative UI works. And hopefully you all were able to see its power. We're slowly starting to wrap our heads around Jetpack Compose syntax. And this time we'll try to build something more realistic. We're used to seeing components like this, which have like some image view on the left and two text views on the right. Very common and we see it on a daily basis. Let's try to break this component down. So what it has is a row that has two child components. The second child component in turn has two more child components aligned in a vertical fashion, one below the other, similar to a column. So let's actually start writing this in code. So we'll create a simple function and annotate it with the add composable annotation, similar to how we've done it before as well. And I described that component in a few words a few seconds ago. I'll use the same words that I described before and add a row and a column. In addition, I want to change the property of this composable. And so we'll use our best friend, which is a modifier. So I want the row to occupy the entire available width. For doing that, I make use of the fill max width modifier. In addition, I also want to add some padding around it. So I add a padding of 16 dp around my composable. I do the same with the column as well, but I just want to add the padding at the start of the column. And that is what I will do. One thing to note is that in Jetpack Compose, we don't have the concept of margins. At the end of the day, padding and margins are basically adding space. So Compose has tried to simplify it and only make use of padding. We'll make use of the same components that we created in our first two examples, and we'll use drawable image and custom text component. We build these components and composables ourselves at the start of this talk. So you all are familiar with this. We'll do what we always do, which is to make these composables generic. And so we'll start accepting values and then passing it along to our subcomposables. When we actually run the app, this is what we see. Now, this is very close to what we wanted. We wanted an image view on the left and two text views on the right. Those are not text views, just text composables. But there is a small difference here. We wanted the title and subtitle to be aligned to the top and the bottom of the image view. But here we aren't seeing that. So let's go ahead and change that. In order to specify constraints to our layout, we're going to make use of constraint layouts, but in Jetpack Compose. We start off in the same fashion like we always have, a custom method with the add composable annotation. We also make sure to pass in parameters in order to make sure that our composable is generic. Next, we use the constraint layout composable that Jetpack Compose gives you by default. And then we make use of the create refs method. What this method does is return a bunch of constraint layout references, and all the constraints that we want to specify, we add it to these references. Next, we add all the three composables that we need. So we know that we need an image and two text views. And so we've created some composables at the start of this talk. We'll just reuse those. With the exception of the image, we previously created the drawable image, but let's assume that we have a composable that takes in an image URL and renders it. We then use our best friend, which is a modifier, and we make use of the constraint as modifier. The constraint as modifier takes in a constraint layout reference. So we start with the title reference, and then we make sure that we add constraints to this. The first constraint we add is that we want to constrain the start of the title to be at the end of the image, and we also add a margin of 8 dp to it. We also constrain the top of the title to the top of the image, exactly what we want. We add similar constraints to all the other composables as well, and then we try to run the app. Before we actually do that, we wrap it inside a card, which is also a predefined composable. Card in particular adheres to the material design specification already, and so we can just simply use it. Let's run the app and we see that we get the desired result that we were hoping for. One thing that I just mentioned was that we made use of the card composable, which adheres to material design specification. Similar to card, we have a lot more composables that we can use that also adhere to our material design specification, and they're already ready for us out of the box. So we don't need to create these composables ourselves. Compose has done that heavy lifting for us, and it's already ready for use. Let's try to tackle building a list in Jetpack Compose. What we created just now was a simple row component. Let's use this row component and show it in the list form in Jetpack Compose. What we've historically used for rendering a list in classic Android is recycler views, and all of us are very familiar with recycler views. But what do we use in Jetpack Compose? Some composables have obvious names like text and image, but that's not the case with every composable. So how do we find which API to use in Jetpack Compose? In order to solve this problem, I created a tool that's available at jetpackcompose.app that tells you exactly the equivalent API that you need to use in Jetpack Compose. So when you enter recycle view on the left, it will tell you that you need to use lazy column items in Jetpack Compose. And that's exactly what we'll use. We'll start off in the same way that we always have, custom method with an add composable annotation, and we'll pass in the metadata that we need. Since we want to render a list, we will pass in a list of person objects to this composable. We just saw that we need to use lazy column items for rendering a list in Compose, and that's what we'll use. And we'll also pass in the superhero item list because it accepts a list of objects. The callback that this composable gives you allows you to specify how you want to render each item of this list. Because we want to reuse the composable that we just created, that's exactly what we'll use, which was the simple row component, and we'll pass in and propagate the metadata that we need. This is all the code that you need to render a list in Jetpack Compose. Do you remember writing all those recycle view adapters, overriding all those methods? A very big goodbye to that because you don't need to do any of that. These 5 or 4 lines of code is all you need to render a fully functional performant list in Jetpack Compose. Let's try to add gestures to the composable that we've just created. The most common gesture that we use on a daily basis is the on-click listener. So let's try doing this in Jetpack Compose. So we just created this component a couple examples ago. And what we want is every time any of the items in the list is tapped, we want to call a method on the view model. So what we do is we just pass in the view model. And because we are adding additional functionality to a composable, modifiers are more often than not the right candidate. So I often just start typing modifier dot and the functionality I'm going after, and then I find the relevant modifier. So as I start typing click, autocomplete goes off, and then there is one modifier that seems relevant, which is the clickable. So that's the one that I'm going to use. What this modifier does is that it allows you to specify what to invoke when this composable is clicked. And here I want to call the method on the view model that I was going after. Now this works fine and there are no issues as far as bugs go. But from a principal point of view, we want to make sure that our composables are generic. However, in this case, because we are passing the view model, the composable knows about the existence of the view model. So this is not ideal. Can we do something better? What we instead can do is we can just pass in the on-click callback and invoke that in the clickable. That way, we don't really need to care about the view model itself, just the functionality that needs to be involved using the Lambda. This way, this composable remains generic. The next gesture that we are going after is the pinch to zoom and drag gesture. If I were to implement this functionality in classic Android, it requires a whole bunch of code. The functionality that we're going after is that a user should be able to open an image, zoom through that image, and also pan through that image at whatever scale the user stopped at. So we'll start off in the same fashion like we always have, a composable function where we pass in an image URL because we want to load the image first. Next, we create two state variables. The first one is to store the value of the scale level, and the second one is the pan offset. It's basically the amount of drag that the user has done as they were looking through the image. Next, we make use of the box composable. Now, box is a predefined convenience composable that allows you to apply common draw and layout logic. We pass to it the network image component that we've seen before as well, where we also pass the image URL and add a modifier and ask it to occupy the max size available on that screen. Since we're talking about gestures, you all would have probably guessed that there is a gesture to take care of this pinch to zoom functionality. The modifier here is the zoomable modifier, which has a on zoom delta callback. So what this callback tells you is that every time the zoom level is changing, it's going to come back with that value and you can use it however you want. What we do here is that we update the value of scale by multiplying it with the zoom delta. That way, if you're continuously zooming it, that value is changing and we're storing it in scale. What we also do is on the image composable, we pass an additional modifier and we call it the draw layer modifier. Draw layer allows you to specify the scale in the X and the Y axis. And because we want the scale to be consistent, we pass the same scale value. This takes care of pinch to zoom functionality that we were going after. This is all the code that it needs, by the way, which is mind boggling to me. The next thing that we're going after is actually panning. So we want to drag through that image. And what we can do is, again, as you would have guessed, use a modifier. In this case, the raw drag gesture filter. So like we don't need to go into that logic, but as you can see, this is all the code that I need to come up with this functionality where I can zoom through that image and also pan through that image. Imagine doing this in classic Android and how much effort it would take. Anytime we talk about introducing something new, it's really important to understand how it provides backward compatibility and what the interoperability story is. So that's what we're going to look at in the next few examples. The first example is about how we can use Jetpack Compose in the existing Android UI toolkit. So we start by creating a very simple activity with the conventional layout XML files, and we use set content view for that. Next, we get hold of a view group that lived inside this XML. So this can typically be a frame layout. What Compose gives you is an extension function on view groups where you can provide a composable to it. So it's the same set content method, but this one is not on the component activity that we saw at the start of the talk, but instead on the view group. We pass in the default value that we had seen before and use the composable that we just created, the simple row component. And this is all we need to do in order to use a Jetpack Compose composable in the existing Android UI toolkit. What about the other direction? What if I wanted to use all the custom views that I've created over the last 12 years in Jetpack Compose? Like, you don't want to waste all that effort that you've done. So there has to be a way, right? And in fact, there is a way. So let's assume that we had this XML file where I was using one of my custom views that I've created. Again, shameless plug here. What I need to do is simply create a composable function. And Jetpack Compose has this composable called Android view that takes in this layout XML. So we just pass that layout XML, provide whatever modifiers we need, and this is it. We don't need to do anything else in order to use any of our existing classic Android views, which is amazing, right? I've been working on Compose since the past year and have created a few resources that I would love to share with you all. The first resource is the Git repo that I maintain with the same name as the name of the talk. So I've been working on this since about 5 to 6 months at this point, and I've added a lot of examples. You can simply search for keywords and hopefully find relevant examples. And all these examples have comments and screenshots. So hopefully it's easy for you all to consume this content. All the things that I missed adding to this talk is all there. So I would highly encourage you all to go and take a look. The next resource is also what I covered in the talk. It's this website called jetpackcompose.app that I built. It helps you find the equivalent API for common things that we do in Android, but in Jetpack Compose. It also links to some of the examples from the previous repo that I showed you all, and also links to the official API docs. So again, that hopefully is useful as you learn about new APIs in Compose. And I'm actively maintaining it and updating it as the APIs change. With that, that is the end of my talk. I had one more big project that I'd been working on, but could not complete it in time. But I'm hoping to complete it over the next couple of weeks, and I'm super excited about that. I'll be sharing more on Twitter, so be on the lookout for that. Always happy to hear feedback. Let me know if I could have done things differently. Thank you guys, and hope you all have a great rest of the week.